All right, diving in today, getting into the fascinating world of centerless grinding. If you've ever found yourself needing to get a super precise finish on a cylindrical part, but it doesn't have any centers, it's for you.
Yeah, or if you're, looking to really boost your production of those nice round components.
Exactly. Stick with us today. We're going to explore a technique that kind of throws those traditional center points out the window.
That's right. And for lots of applications, especially when you're dealing with like a ton of cylindrical parts, centerless grinding has some serious, serious advantages.
So we've been digging deep, going through articles, diagrams, the whole shebang.
It's really remarkable, actually. I mean, this process seems pretty straightforward on the surface, but it delivers really impressive results.
For sure. So today we want to walk you through, give you that solid understanding. How does it all work? Why is it so valuable? And what kind of parts should you be thinking about when you consider centerless grinding?
Sounds good.
So centerless grinding, I mean, the name says it all, right?
It does.
Grinding those cylindrical parts without needing any center holes.
Hmm.
But then the first thing that pops into my head is, how do you even hold the darn thing?
Yeah, that's the question.
How do you control it?
Yeah.
Well, our sources, they all point to these three key components.
Right.
The grinding wheel, you've got the regulating wheel, and then the support blade.
Exactly. Forget about those chucks or mounting between centers, right?
Yeah.
In this setup, the workpiece kind of finds its own little happy place nestled in between those three elements.
Okay, so like a three-way handshake?
Yeah, you could think of it like that. So
Mm.
first up, you've got the grinding wheel. It's the big kahuna for material removal.
The workhorse.
Exactly. And it's typically made of some really, really hard abrasives like aluminum oxide, which is often used for, grinding steel alloys, or silicon carbide, which is another popular choice. And these things spin really, really fast, like really fast.
Thousands of RPMs, I imagine.
Oh, yeah. Now, the specific type of grinding wheel, the grit size, the bonding material that kind of holds all those abrasive grains together, and even its dimensions, all that stuff depends on what you're grinding, how much material you need to remove, and ultimately the surface finish you're after.
Right, right. So that's the brute force.
Yeah.
Now, what about the finesse?
Yeah.
What gives you that really fine-tuned control?
Well, that's where the regulating wheel steps in. This guy is often made of a rubber-bonded abrasive, and it spins way slower than the grinding wheel.
Okay.
And it actually has a couple of jobs. It rotates the workpiece, but it also controls how quickly the workpiece moves through the grinding area.
Interesting. So almost like if you imagine bowling, right, and how you spin the ball.
Yeah, a little bit like that. It's that friction that kind of guides and controls the workpiece.
I like that analogy.
So, for a common method, and this is called through feed grinding, this is like the go-to for simple straight cylinders. And with through feed, the regulating wheel is actually tilted at a slight angle. And this tilt, it's called a cant, and it's brilliant, really. It takes that rotational friction and turns it into this really precise linear feed.
Wow.
And that allows for continuous high volume processing. You get incredible consistency. It's like this clever little bit of mechanical leverage that just gently nudges the workpiece through the grinding zone between the two wheels. And the steeper the angle, the faster the feed rate.
So you can adjust it depending on how fast you want the part to move through.
Yeah, exactly.
That's really, really neat. Now, what about that support blade? That seems like a critical part of the setup.
Oh, absolutely. It just sits there under the workpiece, acting like a steady base between the grinding wheel and that regulating wheel.
Seems simple enough.
Yeah, but its height relative to the wheels and the angle of its top surface, those are crucial. You got to get those set just right.
I see. So any little variation there.
Oh, you'll definitely see problems with roundness and the final dimensions of your part. One of the sources even mentioned that if you're having issues with roundness, check the blade height first.
Yeah.
It makes sure that you've got that consistent contact with both wheels and keeps the workpiece from getting jammed down too hard into the regulating wheel.
Got it. So the unsung hero of the operation,
Yeah, you could say that.
making sure everything is playing nice together.
Keeps it all stable.
And of course, we can't forget about the machine base itself. That has to be rock solid.
Oh, yeah. Absolutely essential. A rigid base is like the foundation for any precision machining, and centerless grinding, no exception. It's got to provide that stability and keep everything aligned so those other components can do their jobs properly and consistently.
Okay. So we've got our main players. Now, let's talk about the different ways to play the game. Our sources go into detail about the three primary types of centerless grinding. Through feed, in feed, sometimes called plunge grinding, and then end feed grinding.
Right. And we've already talked a bit about through feed, which is perfect for those, simple, straightforward cylindrical parts.
Right, like rods, pins.
Yeah, anything with a constant diameter. You just feed it in one end, it comes out the other, precisely ground.
Beautifully simple.
And that continuous flow, it's what makes it so efficient for those larger batches.
Makes sense. Now, in-feed, or plunge grinding, this sounds like it's for the parts that have a little more going on, maybe with heads or shoulders, or even multiple diameters along their length.
Exactly. So with in-feed grinding, the workpiece basically stays put. It's supported by that work rest blade. And then either the grinding wheel and the regulating wheel, they move in towards the workpiece radially, or sometimes the blade and the workpiece, they move together towards the wheels.
Interesting.
But the key here is the grinding wheel. It's often specially shaped, it's dressed, to have the exact opposite of the profile you want to create on the part.
Oh, I see.
So if you need a shoulder or a groove, the grinding wheel will have that shape but flipped.
So it's like a stamp, but with a high-speed abrasive wheel doing the stamping.
That's a great way to visualize it. And then you've got end feed grinding. This is for a bit more specialized applications like making tapers, the kind of shapes you'd find on needles or valve stems.
Oh, okay.
So the workpiece, it gets fed in axially, straight up against a stop, and the grinding wheel is set at an angle to create that taper. Once you've ground that taper to the length you need, you retract the part. It's not as common as through feed or in feed, but it's the way to go for those conical geometries.
All right, so we've got our three main types. Now let's talk about why you would choose centerless grinding over, let's say, traditional external cylindrical grinding, where you do use centers to hold the part. Our sources list some pretty compelling advantages.
Yeah, for sure. Centerless grinding really shines in certain situations. One of the biggest benefits, it completely eliminates the need for those center holes.
Right, no more drilling and prepping.
Saves you time. And those center holes can actually introduce inaccuracies if they're not perfect or if they get damaged during handling. I even came across this story about a company that makes these tiny little precision pins. They switched to centerless grinding and they saw a massive drop in their reject rate,
Wow,
all because they got rid of those tiny, delicate center holes.
that's huge. So you're saving time and you're getting better quality.
Exactly. And don't forget about those production rates. Especially with through feed, you can really crank things up.
Yeah, continuous processing, less time loading and unloading parts.
Makes it so much easier to automate. We're talking thousands of parts per hour in some cases.
It's almost like an assembly line for grinding.
Pretty much. And here's another thing. The accuracy and roundness you can get is outstanding.
Which is interesting, because you'd think holding the part between centers would be more accurate.
You'd think so, but that three-point contact with the grinding wheel, regulating wheel, and the support blade, it actually creates a self-centering action. Like if you try to hold a ball with three fingers, it naturally finds its center.
Right, right.
And that can lead to super round parts, sometimes even better than what you'd get with centers, especially if the workpiece isn't perfectly round to begin with.
That's pretty counterintuitive.
It is. And then, those long, thin parts, the ones that like to bend if you try to hold them between centers, centerless grinding is a game changer for those.
Yeah, all that support right where the grinding action is happening.
Exactly.
Yeah.
That support blade and the regulating wheel, they team up to prevent any bending,
Yeah.
and you end up with better straightness and a more consistent diameter along the whole length of the part. Plus, all that stability usually leads to a really nice surface finish, too.
It's all coming together. Now, our sources actually included a little cheat sheet to help us out.
Oh, yeah.
They had this nice table comparing centerless grinding to traditional external cylindrical grinding. It is. So with centerless, you've got that regulating wheel and the blade doing the holding, no center holes needed.
Perfect for high-volume, simple cylinders.
Very low loading times with through feed.
Potentially very high roundness, great support for those slender parts, so less deflection.
Now flip over to external cylindrical grinding.
Right. You're typically using centers or a chuck. You usually need center holes.
So better for lower volume, maybe more complex shapes.
Higher loading times because you got to mount and center the part.
Roundness depends on how good those center holes are.
And more prone to deflection with those long, slender parts.
It's worth mentioning, external grinders still have their place.
Oh, yeah, absolutely. For those really intricate profiles, or if you just have to have center holes in the finished part, external grinding is the way to go. You got to pick the right tool for the job.
Always. Now let's zoom back in on that regulating wheel.
Okay.
It's clearly doing a lot more than just spinning the part.
It is. It is.
Our sources really emphasize how crucial it is to the whole centerless grinding process.
Right. And, we talked about how it makes the workpiece rotate at a controlled speed, which is slower than the grinding wheel, thanks to that rubber bonded composition.
Yeah, lots of friction.
Tons of friction.
Yeah.
And that controlled rotation, it's vital for consistent material removal and getting that perfect finish.
But there's more to it than that,
Oh,
right?
there's a lot more. First off, if you've got too much slippage between the regulating wheel and the workpiece, you're going to have accuracy problems.
Uh-oh.
Not good. And then we talked about how that slight tilt, that cant, in through feed grinding creates the force that pushes the part through.
Right. Controlling the feed rate.
Exactly. The angle of that cant dictates how fast the part moves through the grinding zone, but it also works with the work rest blade to hold the workpiece nice and secure.
Teamwork.
Exactly. And that's what ensures that 3-point contact with the grinding wheel. And, this is something I found pretty interesting. The rubbery nature of the regulating wheel, it actually dampens vibrations.
Oh, wow.
Yeah, it's got a bit of give to it, so it absorbs some of those vibrations that happen during grinding. And that can really help you get those finer surface finishes and improve the roundness of the part.
So a hard regulating wheel wouldn't be as good.
Nope, you wouldn't get that same vibration damping. And just like the grinding wheel, the regulating wheel needs some TLC. You got to dress it regularly, remove any buildup of material, make sure the surface is clean and consistent.
Okay.
If it gets too smooth or clogged with swarf, all those little metal chips, it'll start to slip. And then, well, accuracy goes out the window.
Makes sense. All right, so taking all of this into account, what kind of parts are just screaming centerless grind me?
Well, if you're doing high volume production of cylindrical parts, that's a big one. We're talking pins, rods, tubes, all kinds of shafts bearing rings and races, rollers, valve stems, injector needles, even fasteners like screws and bolts. And with in-feed and end-feed, you can also handle parts with simple profiles or tapers.
So lots of options.
Oh, yeah. So those basic cylindrical shapes, perfect for through feed. Things like motor shafts, piston pins, drill bit blanks, precision rods.
And then in feed.
In-feed is great for parts with features like bolts with heads or hydraulic spools with grooves and multiple diameters. And for those tapers on valve stems and needles, that's where end feed comes in.
And because it's so efficient for large quantities, I bet it's used a lot in the automotive industry.
You bet. Centerless grinding is all over automotive manufacturing for parts like axles and bushings. The speed and the potential for automation are perfect for those high-volume applications. Plus, the level of precision you can get is incredible. You can consistently hold tolerances down to less than a micrometer.
That's tiny.
It is, and that's super important for high-performance parts like bearings or fuel injectors. And let's not forget about those long, thin parts that are a pain to hold with other methods.
Yeah, centerless grinding just eats those up.
It does, and it's not picky about materials either. It can be used on a whole range of stuff, from different types of steel to aluminum, brass, titanium, even some ceramics and plastics. The key is to pick the right grinding wheel and the right coolant for the material you're working with.
Speaking of coolant, our sources make it very clear that it's not just an afterthought. It's essential for centerless grinding.
Oh yeah, absolutely essential. You're removing material at high speeds, and that creates a ton of heat. If you don't have good coolant flow, you're gonna have problems.
Like what kind of problems?
Well, first off, heat damage to the workpiece. You can get burns, discoloration, even unwanted changes in the material's properties.
Oh, wow.
Yeah, and it can affect dimensional stability too. If the part heats up too much, it'll expand, and you lose accuracy.
Right, so it's protecting the part.
It is, and it's also protecting the grinding wheel. You don't want it overheating and breaking down or getting glazed over.
So it's protecting the tool and the workpiece.
Both. And it also acts as a lubricant, reducing friction between the grinding wheel and the workpiece, as well as between the workpiece and the regulating wheel and the work rest blade. That smoother cutting action gives you a better surface finish, extends the life of the grinding wheel, and can even reduce power consumption.
Multitasking coolant.
That's it. And then there's the flushing action. The coolant washes away all those little metal chips, the swarf, and those abrasive particles, keeps the grinding wheel from getting clogged up, which would make it less effective. And it also prevents those little bits of debris from scratching the surface of the workpiece.
Makes sense. And it sounds like coolant also plays a big role in the overall stability of the process.
For sure. Keeping temperatures under control helps the regulating wheel maintain a good grip on the workpiece. If things get too hot, the regulating wheel surface can change, and you start getting slippage and inaccuracies. And a lot of coolants also have rust inhibitors, which protect both the machine and the finished parts from corrosion. And effective coolant delivery is key too. You need enough volume, sometimes even high pressure, to make sure it gets to that critical grinding zone.
No skimping on the coolant.
Absolutely not.
So bringing it all together, centerless grinding seems like this really elegant and incredibly efficient method for achieving some seriously impressive precision on those cylindrical parts, all without relying on traditional centers.
It really is. And it's the perfect choice for high volume production.
And all that efficiency,
Yeah.
it comes down to that precise dance between the grinding wheel, the regulating wheel, and that trusty support blade.
Yeah, all working together in harmony, with that constant flow of coolant keeping everything running smoothly.
It's a beautiful system. And when you think about the level of precision and efficiency that centerless grinding achieves, it really makes you wonder what other manufacturing processes could be revolutionized by similar out-of-the-box thinking.
It does?
Maybe it's about challenging those fundamental assumptions
Ah.
about how we hold and manipulate materials during manufacturing. Something to ponder.
For sure.
Well, thanks for joining us on this deep dive into the world of centerless grinding. It's been a fascinating exploration.
Anytime.
Until next time.